all you, recording in progress.
Great.
Great, okay. Chris has done a great job in finding us speakers, and he's got a line on one for April, and who's willing to do a live meeting back at the Grand. Or I should say an in-person. You're doing a live meeting too, Tom, but I mean an in-person meeting.
Right.
So we're hoping after over a year and a half of having Zoom meetings that we're going to start in-person meetings next month. So watch your email for the newsletter. And unfortunately, I will be driving along with my wife to San Francisco on that day, and I will be unavailable. So I will find somebody else, one of our other board members, to host that meeting. It's a shame I can't be there. But the best philatelic show in California is end of April each year, and I got to go to Westpex in San Francisco. I'm on the board of directors of the Western Cover Society, and their secretary, and I have to go there for a meeting. I'm also doing my first philatelic exhibit. So anyway, we're looking forward to it, but unfortunately it conflicts with next month's LA Basin meeting. Well, it's really a pleasure to have Tom give this presentation and to see Jay Namson here. I worked with both of these fine gentlemen, and they taught me a lot at ARCO in the old days, and they sure taught me a lot about structural geology, which I was able to use to some advantage. Had a lot of fun doing that, especially using that Halliburton software that Jay taught me to use. And you know, I can't think of the name of it right at the moment.
Lithotech.
Lithotech, thank you. Well, it's been 6 years since I've retired, and I've not been back with that stuff, which is unfortunate. But now I'm growing tomatoes and doing into gardening and things like that. Anyway, without further ado, I want to introduce Tom Davis. He's got a PhD, bachelor's from UCLA, and a PhD from UC Santa Barbara. He's a structural geologist by training, a registered geologist. He's got a lot of experience in various tectonic settings. And we're going to hear today, obviously about Bangladesh, but I remember working with him at ARCO International back in the old days when he was interested in Pakistan. I believe I worked with him briefly on that. And we also had exposure to Bangladesh. So without further ado, I'm going to turn the meeting over to Tom.
All right, thank you, Scott. Okay, I'm just going to jump in here real fast and let's see if I can find the darn thing. Okay, and then I'll present.
We can see it.
Can you see it now?
Yep.
Okay. All right. So this talk is, it's really a combination of a couple different things. I've been working slowly on kind of a combination of what is going on in Bangladesh as far as natural gas. We wrote a paper, Badrul Imam, who is a geology, petroleum engineering professor at the University of Dhaka in Bangladesh. We put out a paper back in December, and there's a link on there. It was published through a British journal called GeoXpro. You can go and download the paper. It's completely free and all that stuff. And then, so we used some of that. That was more of a paper to try to encourage more gas exploration in Bangladesh, which is greatly needed that you'll see in the talk. And then Dr. Imam gave a talk to the Petroleum Engineering Department at USC recently, and that's also, if you look at the bottom of the first slide there, there's a link to that, so you can hear him. So what you're going to see is a combination of that stuff, because Dr. Imam and I are putting together something more extensive that will deal not only with the need for natural gas exploration, or more natural gas exploration in Bangladesh, but also with where Bangladesh sets in the whole energy transition question that's going on today, and a thing called energy poverty, which I will define a little bit, and these will be additions. So it'll be that thing we're heading towards will be a more general kind of, more general interest, not just a straight geologic sort of exploration talk. All right. So here's Bangladesh. I'll do a little country summary, and that's the flag of Bangladesh. I was going to look up the history of that flag, which I actually don't know, but it's kind of, I like its simplicity, let's put it that way. And first I'll talk about, like I said, the country and energy. Okay, so what we got here up in the upper left is just kind of a little snapshot of, the Indian Craton and the Bay of Bengal, and the BD in there shows Bangladesh. And it's basically where the Ganges and the Brahmaputra rivers come together and form this large delta system. Just south of Tibet in the high part of the Himalayas, west of Myanmar, which is over here, another area that I've actually put a lot of effort into. And then, of course, Bangladesh used to be part of the same country with Pakistan. This was West Pakistan, and that was East Pakistan, up until about 1971. In fact, this Saturday is the Independence Day for Bangladesh, when it declared its separation from West Pakistan. And, there's a whole history there. It's a very involved and very interesting history if you ever want to go into it. That it starts with, well, it goes way back in time, but it's a very interesting history. And of course, the British were in the middle of it with the British India, and then there was partition in 1947. You had Pakistan, West and East as one country, and then separated in the early 70s. All right, so the land area of Pakistan, or Bangladesh, excuse me, it's about 150,000 square kilometers. And I put this little map down here to the lower right to kind of show you the size of it with respect to something that we'd all recognize a little better, superimposed on a map of the area around Washington, D.C. So, the area that I've actually worked in the field is down in this area called Chittagong, the Chittagong Hills region. But, it extends from the very base of the Himalayas down, through the Delta area. And then this Chittagong region here are the start of the Indo-Burma fold belt, where I'll show you in the geology where India's craton has collided into the main Asia mass. Okay, so looking over to this lower left diagram, a couple of statements here. The Ganges Brahmaputra river system, one of the largest in the world. It forms the largest delta in the world, and to make it that includes what goes off into the Bay of Bengal. It's got the highest sediment load carried to the sea in the world. That is kind of a interesting geologic fact that we'll get into a little bit more, but it's a very thick sedimentary Cenozoic age, Cenozoic pile here. And then it's the largest deep sea fan in the world, which extends pretty much over the entire Bay of Bengal, which I don't even show all of it in this map here. And incidentally, I get a lot of my stuff if you want to look up a country someday, I don't know if you guys are aware of it, but the best place to go is to the CIA World Fact Book. It's a great place to get a lot of information. Okay, so here we are with another map of Bangladesh, and shows how it's on the left, it's divided up into these 8 administrative divisions. Again, my experience has mostly been in Dhaka and down worked in Chittagong in the field. And the government type here, it's a democracy. It's a parliamentary republic with 2 major parties. They've been in power pretty much since the independence, Awami League and the Bangladesh National Party. The population of the country shown up here in the upper right, it's a little over 165 million now, 8th most populous nation in the world. Median age is about 28 years compared to the United States, which is, I can't see what I wrote down here. It's covered by that little thing, but it's about 36 years or somewhere around that. Bengali is the main ethnic group. There are some smaller ethnic groups, especially in like the Chittagong area, in the fold area up in the hills. The language is Bangla. I'll give you a sample of the script here, what it looks like. Primarily a Muslim country, although there's a fair minority of Christians in the country, okay? The population shown here relative to the United States here, it shows the growth from 1800 and projected out to 2100. And you can see the United States just keeps increasing to over 400 million. Bangladesh, actually, interesting enough, will probably peak, at least according to the world, wherever I got this information, World Data, World Bank, with the various sources, and we'll peak about 2054, somewhere around that. Population density. Bangladesh is one of the, for the large countries of the world, and so I'm not counting like Hong Kong or Singapore, it's one of the most densely populated countries in the world. And you can see on this graph over here, I basically got what the projection is out to 2057. United States is about 42 people per square kilometer. Bangladesh is going to be around 1,500 people per square kilometer. And this graph goes on back to 10,000 BCE, before the Common Era, okay, which is essentially BC. Interesting, another place to get a lot of good data worldwide is this World Data Bank, or World in Data, and it's sponsored by this Global Change Data, whatever it is, I've forgotten exactly the abbreviation, but it's run out of Oxford University, and it's a great source for stuff. And it's got this interactive sort of tool that you can use for all sorts of population things and energy stuff. Can I somehow close this little thing on the side? Hide self-view. That doesn't do that. There's a little thing on the side. I'm trying to get rid of it.
Is it the like?
Yeah, that does it. Okay. Okay. So some of the energy implications of such a dense population. One is land use, and I'll get into that a little bit. But it's because there isn't that much good land left for things like solar farms because of the high population density. And then we're going to talk about power density a little more, but just as a definition, I'm talking about mainly power density right now for electrical generation, because that's the big need in the country. And it's basically how much energy flow can you get out of a certain area. And I'm showing there a couple of definitions. It's watts per, in the top one, per cubic meter, or you can do it per square meter. There's various types. Another good source of this kind of information on things like that is Robert Bryce, who is an author on energy things, and he's also a reporter, and he's got a very, if you haven't been on there, it's got a very good podcast. He's got now at least 100 podcasts on different energy issues, and I get a lot of information from him. Okay, so this is what a lot of Bangladesh looks like, this photo up in the upper left. And this is the question there posed is being asked by Dr. Imam is like, well, so the government has planned a lot of renewables, especially solar. But the big question by people that are, I'd say, out of the government, but more in the energy business, so where are you going to stick them? Because if you look down just below that image, you can see the percentage of land use for agriculture is very high relative to other countries. It's running about 35% in really most agricultural countries. The world average in 2018 was 30. They used 32 countries to come up with an average, and the reason they use 32 is because the 32 are big agricultural countries. For comparison, or ones that are very involved in agriculture. The map on the right kind of shows you, just with some color coding, how much Bangladesh is taken up by plantations, orchards, agriculture. That 71% that's over to the left there that I show. And you can see all that light colored stuff that, kind of the yellow and then merging on to sort of a kind of a reddish purple looking color. Well, that's all small farms, tiny small farms. Okay. So agriculture in Bangladesh is characterized by mostly small plots and very widespread, except for these forest regions, one down in the Chittagong Hills, which this is jungle. I mean, it's a jungle. And in fact, if you get back against Burma or Myanmar, it's a jungle with wild elephants still and tigers. I mean, it's quite an interesting place. And then there's another region down here in the very southwest called Kaluna, and it also has extensive, and mainly mangrove forest down there. And but again, those are really the two only areas that aren't extensively have extensive amount of agriculture. Okay, so what's the energy mix? And talk about economic growth. So the pie diagram on the left shows you kind of the interesting part of the mix here is mostly fossil fuels. You've got coal, liquefied natural gas, and oil. Okay. And that makes up, a large part of the energy use. Biomass, on the other, their biomass is not what we think of it as in biomass as far as energy use. Now, this is energy use, okay? So this is how they are, the sources of where their energy is coming from. And this biomass, and so it includes everything. We're including here, it's not just power generation for electricity, but this is like the whole, everything, transportation, the whole works. And that biomass is largely by burning dung, animal dung, and various plant matter at home, which is not a good thing for health reasons long-term. It's especially damaging, and you can go on and look up UN stuff on burning of dung and various biomass at home where people don't have access to natural gas or to some sort of electrical power to cook on. It's very bad, especially on women's health, because women turn out to be in these countries the main provider or the main cook. And the amount of lung disease, asthma is, it's one of the largest early killers worldwide that there is. So Bangladesh is actually 30 years ago, it was, a lot of people thought it was kind of a basket case as far as, when it first had separation or partition from West Pakistan. But the economic growth has been incredible over the last couple of decades. And it shows there with that red arrow that it's at, oh, sorry about that. I should turn that thing off. It's been about 7.2%. Really for almost the last 2 decades, it's been in the 5 to 7 range. It's one of the highest growing countries in Asia. And down here in the lower left, it shows the gross domestic product per capita, and that red arrow is for 1980. So, and then I show over here the electrical use and how much of it's coming from, that's in terawatts per year coming up here. And that's how much of it is coming from fossil fuels, the percentage, and there's renewables down at the bottom. Okay, so what I try to point out here in comparing these 2 diagrams is that from 1980, that starts in the arrow is at 1980. This starts at 1980. You can see the tremendous growth that has gone on here. Well, that's been that use of energy that's reflected in this incredible growth that Bangladesh has had in the last 40 years. Okay, and so it goes to the very thought that the economy. There's a lot of economists that will, especially in energy, that say, well, energy is the economy. It really, without energy, you don't have an economy. And this is just a case of that. Okay, so on the left here, I'm showing the power sources in energy mix again. Now this is pretty much for electrical generation, which is very important in Bangladesh as it is anywhere. And about 95% of the country has been electrified. So they have been able to do that over the last 40, 50 years. And this shows, how much generation there was in megawatts back in 2010. And it's 95% fossil fuel. Okay. So if you come down here to 2020, it's about 93% fossil fuel. So it's still very high. That's in counting all this furnace oil, diesel oil, the coal, natural gas. What is happening, this graph shows kind of what has happened since 2010. Well, the coal use actually has gone up dramatically. Natural gas has gone down. We'll see in a moment why that's so, but it's mainly, it's to replace what they're not having in natural gas availability, okay? So I state out here that power and energy in Bangladesh are fossil fuel dominated and will remain so for decades in the future. There are no high density and inexpensive power alternatives. There just aren't any. You'll see there's that darker blue line. Well, that's nuclear power starting to come in. But again, renewables, and there's been a lot of effort in the country with renewables, especially coming from the US and Western European countries. It's still a tiny bit of the power generation that goes on into the country. Okay, so this shows our per capita generation in kilowatt hours, but basically by the year going out. Here's the United States. Here's what we did in 2020. So we're using about 12,000 kilowatt hours per capita in the United States. Interesting enough, it's kind of a side thing. It's, Norway, I didn't put Iceland on here, but Norway and Iceland they're off the charts. I can't remember exactly where Iceland is, but it's above Norway. And that's because it just has such an abundance of energy. And this goes down, it just basically that little table or little chart there shows you where Bangladesh is. So they're basically they're using about 1/25 of the power generation that we are in the United States. Okay. And this shows you basically what's happened with these countries over time. Okay. So still they've grown and they've had fantastic growth and lots of energy use in the last 40, 50 years, but it's insignificant compared to what we have in the West. So this brings up the question of energy poverty. And I think, again, this author, reporter, Robert Bryce has, here's a good example of this. And that is roughly 3.3 billion people on the planet live in what he refers to as the unplugged world, where the per capita electric use is less than 1,000 kilowatt hours per year. That means about 45% of the world's population subside unless less electricity per year than the average American family uses to keep their refrigerator running. About 1 billion of the people of the 3.3 have no access to electricity at all. So this is where energy poverty resides. And there's probably about 40 or 50 countries in the world that are in the energy poverty situation. This shows you how the use of natural gas as the principal fuel for electrical generation in Bangladesh really over the last, it's a projection. It goes for the last few years and then out to 2040. And, things were pretty good before about 2018, 2017. The supply and demand, the red is demand, supply, and this is in country natural gas. Back then, they were pretty closely matched. So Bangladesh was using a lot of its own energy source, natural gas, to fuel much of the power generation. But what's happening now is, of course, there has not been as much exploration for natural gas in the last 20 years. And the demand, because of that economic growth, continues to rise. And the supply is declining and will continue to decline. Okay, and this is in that article, that GeoX Pro article discusses it more. So, one of the things I show in the middle here, statement is preventing economic decline will require a combination of new natural gas discoveries and reserve growth. And that can only happen with future drilling, more exploration, more than they've had in the last 20 years, let's put it that way. Or you're gonna have to expand greatly, both reliable and, baseload energy sources, such as coal or nuclear power, because it doesn't look like, despite all the effort, that renewables are going to be able to do this over the next several decades. Okay, this gives a little more detail on the projection out from 2021 to 2041. And again, it shows you kind of where the country thinks the energy is going to come from. And the yellow is, and the gray bars there, they represent more or less the imports. The yellow is coming from imports of LNG. The gray are energy transfers from mostly India, actually. In other words, power being bought from, electrical power being bought from India. The lower parts of the graph, the blue and the brown, they basically represent the supply from, in-country gas sources. And the problem, without reading all that stuff down at the bottom, the big problem is Bangladesh has been forced, because of the declining in-country sources, to buy more and more LNG. Well, if you know anything about again, are energy problems of today. Natural gas, or LNG, excuse me, was very expensive to begin, has been expensive for the last 2 years. It really got dramatically expensive about the last 2 years, especially in East Asia. The Japanese and South Koreans had just been buying this stuff up, and they really ran it up last year. Well, with the new problem that we have stemming out of a number of different things, including the war in the Ukraine, the prices have shot up even more. And if you know something about what's going on in Europe right now and their dependency on Russian natural gas, you know, they're trying to get gas now from the Persian Gulf, mainly from Qatar. And that also is driving up the price. So poor old Pakistan, or poor old Bangladesh, is going to have to pay a lot more. I mean, the prices they were up about 3 times. Now they're up like more, like in the 5 to 7 times amount, okay? Anyway, that's another reason to try to explore more in the country. This shows you the, again, a projection out as far as, you know, where the power generation is going to come from. On the left, the bar is megawatts. So this is mostly, it's basically electrical generation. You know, now it stands at about 35% coal and 35% gas. But you can see what happens in the future. The black is coal. So they're going to be forced into the situation of burning much more coal. Hopefully they can make the gas, they can have more gas discoveries, because that's what this is projecting. They will make more gas discoveries. Otherwise, they're going to be using a lot more coal. And then these are power imports. This would include the LNG. And then the gray is nuclear and renewables. Well, this is mostly nuclear. There's a plant being built by the Russians. It's a 2.4 gigawatt plant west of Dhaka. It shows you there's some interesting politics here. And, you know, you may have read that, you know, most of the countries of Western Europe and Japan and South Korea, they've condemned the Russian invasion in Ukraine. But, you know, the countries in South Asia, India especially, it's notable, they have not. Bangladesh has not either. And they're very dependent on the Russians right now because of the things like this building of this power plant in Bangladesh is a big deal. And this particular type of water energetic reactor design is also, these are very popular now. And so Russia is building some in India too. And so this is part of the problem. There's a whole geopolitical aspect to this stuff that unfortunately the US seems almost out of the game on this stuff. I mean, I could go into that, but we're not being as aggressive as we could be in this realm. So let me jump onto the geology here real quick. So we started out, you know, India back 125 million years ago. It was part of Gondwanaland and it all broke apart. And India drifted northward over time. That's shown here in this diagram. So what we're really concerned about is what's happened the last about 10 million years, you know, as far as where things are, the traps and the natural gas traps and such. This diagram shows you kind of what the tectonic setting looks like, you know, today and going back about 10 million years. And we have an inland basin up here called Surma Basin. These little circles on here, these are gas fields that have been discovered. And then we have a fold belt down here, that this, what they call Tripura, or down here it's called Chittagong fold belt. Then the fold belt continues back in here. It's mostly non-petroliferous rocks, but and then you get over into Myanmar, Burma, and you get, again, oil and gas over there. Some of the things to keep in mind in here is that that's the Eocene shelf edge. So everything up here is pretty shallow. This, I'm going to show you these two cross sections here. They'll give you a little better idea what it looks like in, in the third dimension. Okay, so the top cross section, north is on the right. And we start on the left here. You can see here's the, really the Indian plate oceanic crust, or the oceanic crust off India, I should say. Here's the Indian plate, more or less. The continental crust is being subducted under the Himalayas and making the Tibetan Plateau back here. And so the Surma Basin, it's filled with really Eocene, post-Eocene and post-Eocene sediments, and that have, because at that time, India was getting pretty close to Asia. Most of the source rock is natural gas prone. It's type 3 kerogen, woody kerogen. Same goes with out here under the Bengal Basin. And what's happened over time, because of the river systems, the large river systems, is the delta is just prograded outward out into the Bay of Bengal here. So the red line here shows you the Bangladesh portion. Okay. And then in an east-west sense, here's the Indian Shield or Craton. Here's that Eocene carbonate shelf edge. And again, we have out in the offshore, just south of, the onshore delta part, we've got natural gas resources. And then here's a fold belt where there have been gas discoveries. And then we go into Myanmar, and there's a fork basin over in Burma that has oil and gas over there. And you see what's happened here is the oceanic crust is being subducted, again, due to this collision between India and Asia. And there's this little Burma plate caught in here. Okay, so the map on the upper left shows you where some of the fossil fuel resources that we know about are. There's the coal area up in the northwest. There's peat that's in the very young deposits that is exploited. And then the natural gas area is shown in that red ellipse. And what we know today is pretty much what's on shore. There's been a little bit of offshore discoveries, but these are all, it's basically folded structures, either up in this northern basin or down here in the Bengal Basin. And this shows you what probably one of the most active foreign companies in the past in Bangladesh was Shell. And they basically they ran back then, this was the 60s, so that a lot of the stuff was identified off 2D seismic, these folds. It looks like this in cross-section, these gas fields. And, they had a very high success ratio and discovered a number of TCF-sized gas fields. And this is more or less what's run the country for quite a while. Is the natural gas being exploited from these. Now the source rock out here is Oligocene source rock or even older source rocks. Most of the Miocene and Pliocene, even Pleistocene deposits where there are reservoirs, it's really the reservoir sequence. So it's the source rocks is deeply buried. This shows you this map here where the USGS back in 2001 evaluated the area, Bangladesh. And the contours on here, the green ones are estimated to the base of the sedimentary cover, the depth to the base. And these are in meters. And then the brown contours are gravity here. So you get gravity highs up here and here. And then the numbers on here, the black numbers, they're in TCF. So this is what the USGS assessed, predicted for the basins. So we'd have, even though this has not been exploited, it'd be nearly 3 TCF of gas. And then in these areas, these are the gas fields the 27 gas fields that are known today. And it totals up to about 30 TCF of gas that they assessed in here. Now, this is undiscovered. Okay, so this is yet to be, when the USGS did this work, of course, most of these gas fields they were pre-2000, the year 2000, so they had already been discovered. So we think there's about 30 to 40 TCF of gas remaining in this general region, okay, of the, well, we didn't count that one too, more or less in the Bay of Bengal, or north of the Bay of Bengal. The offshore is a different story because so little is understood about it. There's been some gas discoveries here, but not a lot of work has been going on down to the south into the main part of the offshore basin. Let's see. So this shows you, again, kind of layout. The color coding here is, this is where the deep delta basin is. This is a cross section, that red line showing how deep it gets. Again, this is in meters, so that's 20 kilometers. We're down here with the sediment load. Again, your fold belt to the east. This is where some gas discoveries, older gas discoveries have been made. This shows you the section, more or less your clastic reservoir sequences are up here. Fortunately, there's a lot of shale seal on this stuff in the Miocene, Pliocene section. And the red dots here indicate where gas has been discovered. Our source rock is down in the Oligocene and probably older. Okay, it's a very rich source rock in here. And there's a number of studies on that. This kind of just a very cartoon-like thing that shows you, the migration pathway and where the yellow is basically the reservoirs and your source down here. This is part of, comes from Imam's work, that you can, if you listen to that USC presentation, you'll get. Okay, so what are the play types here? I'm not going to go into all this in detail, but because of the low frequency of exploration drilling, it really the potential of the country has just not been realized. And so again, Imam and I are making the case. There's a lot of things still to drill. There are structural plays. I'll show you some of those in just a second. There's a number of different types of structural plays. One I should really note is a deep water fold belt offshore. Completely, they know it's there. There has been some 2D seismic out there, but undeveloped completely. And if you know anything about worldwide deep water fold belts, they can be extremely rich and very commercial for oil and gas problems. Okay, so what about the structural plays? So here's a map that I made years ago that should have gone hills. And it's showing all these north trending anticlines and synclines. There's some cross sections there shown that go with it. Here's a Google Earth image that shows you can make out these big structures. They're really long structures and they have several different closures along the way. Very interesting place. Again, only partially understood and developed as far as gas. Here's the cross sections. I'm showing the Oligocene source rock down below. where these major detachments that are interpreted are shown are mostly at the base of the reservoir sequence. Okay, so this T-Palm and Bocaville and Bulan, these are where we know there's gas in these are the gas reservoirs. Okay, and again, a lot of these big structures have been only partially or not tested or only partially tested. One of the problems back in the 60s was just the infrastructure for drilling out here. Many of these big anticlines, because they've been uplifted so recently and they have such good seals on as far as hydrocarbon, keeping hydrocarbons in the subsurface, is they have very high pressures, almost to lithostatic. And this presents some real drilling problems. But, this was a problem back in the 60s. This doesn't have to be a problem today with modern drilling. Okay, and then a completely almost unutilized or unexplored set of plays are the stratigraphic plays and we list out a whole sequence of them here, but you can look at this GeoX Pro article if you're more interested in that in the discussion. And then there's some geologists like Dr. Imam believe that there's a unconventional natural gas play that remains untested in the country too. Okay, so here's what's been going on recently as far as the offshore. Of course, Bangladesh is up in here in the Bay of Bengal. The deep water delta continues, or fan just continues on out, makes up almost the entire Bay of Bengal. Here are the discoveries that have happened. This is all from India, this Mahanadi, and then there's one here within Bangladesh's water. These are recent gas discoveries. And there's some off in Myanmar here that the Australians and the Malaysians are exploiting. So the idea is that, given this setup, there ought to be more, even in the shallow portions of offshore Bangladesh. And again, the deep water fold belt remains pretty much untested, unexplored. This just to show you what in that offshore Myanmar, offshore India, those discoveries were not structural traps so much, they were based pretty much on turbidite models, okay? And so that's something to bring into the picture that has not been used. Again, most of Bangladesh's natural gas fields are structural. The ones that have been discovered are structural traps. Here's where the activity is in, this is all Burma or Myanmar blocks, okay? So there's discoveries right adjacent to, this is Bangladesh up here. And so this should be an area of great interest. And this shows what it looks like. That line, that boundary line there is this boundary line here. So this is called the Arakan area here. It's also called Rohingya. And if you know anything about Southeast Asia politics, it's been this area where the Burmese have caused a real problem, with ethnic cleansing, basically, and driven out all the or many of the people that lived in this onshore area. A lot of them are now up in Bangladesh, in refugee areas. Very, very sad and unfortunate situation. This map over here shows you the blocks that Burma, Bangladesh is offering up. Okay, so what are this energy transition and CO2 emissions? I want to just cover that a little bit in Bangladesh. What is the energy transition? You keep hearing about it. So I just went to a renewable source, the International Renewable Energy Agency. It's the pathway towards transformation of the global energy sector from a fossil fuel based to a zero carbon system by the second half of the century. And this is driven by the need to reduce CO2 emissions to limit climate change. On the other hand, for people that look at the energy business in detail and look at government policies and how things work out, there's outliers like Roger Pilkey Jr., a professor at the University of Colorado, very interesting person who's got this iron law of climate policy, which says when policies on emissions reductions collide with policies focused on economic growth will win out every time. And this has stood the, this is iron law has been, he got a lot of pushback on this, but it's basically been it's been working for 30 years. There's been no, nobody has, no company or country has done this, has violated this iron law climate policy. I mean, the Europeans got themselves in kind of a tight situation with Russia recently, but even the Germans are, they're having a big look at their energy policies. All right, on to the renewables. So you can see here, the best thing to do here is look at, mostly if there's anything is going to happen or has happened in renewables in Bangladesh, it's in solar. And, we're at 351 megawatts power, as compared to 25,000 megawatts of power. So the share of renewables in the country right now is very tiny, 3% or possibly even less. This is the target the government has because Bangladesh went to COP26, and this is what they told the people, at the people concerned, the UN-sponsored climate concern conference, what they were going to do going out to 2040. And, they believe that their renewable target will be 24,000 megawatts. The people on the ground in Bangladesh that are not tied to the government or to this kind of thought, they have no confidence in this at all. They consider this just a political statement for the West. Here's carbon footprint of Bangladesh. So, even if they start using a lot of coal, they're not even close to, being an issue. Consumption in Bangladesh will increase following commissioning of several coal-based power plants. We see all the need for that. But the range of emissions will be, in the 30 to 40 megaton area, and that's nothing compared to, what India and China are going to be putting out, or the US for that matter. Okay, so conclusions, and these are pretty much from Dr. Imam. It's his country, so I kind of left it up to him, but I think he's got a pretty good finger on on the pulse there. And so natural gas will remain as a primary energy feed of Bangladesh for the near to medium term future. So going out, maybe 20, 30 years. Imported LNG will cover the shortfall, but the high spot prices are going to be a challenge to the economy. I mean, when you more or less are paying 4 or 5 times, 6 times what you were paying for energy, it's going to hurt. It's going to be a big headwind. Present energy crunch is due to not exploring enough. The country has its own gas resources. A bunch of international and national agencies have testified to the very high potential of gas remaining in the country. And the international ones, there's a big German study was done, Norwegian study was done on the gas potential. USGS, I showed you that one. And they all come to the same conclusion, very high potential, maybe 30 to 40 TCF remaining onshore in the shallow waters. And then, of course, the deep water stuff that's not even considered in this, in the projection. Share of coal will increase, but it'll be, as far as the commitments that Bangladesh has to the world community, it'll be within what they're being allowed to do. Development of renewables, it just takes place at a much slower pace than the government targets. And the scarcity of land for solar development is one of the main constraints. Okay, I'm going to stop here, and I'm open to any questions you guys might have about this.
I noticed that I didn't see any drilling on any of those offshore islands, those large islands just offshore in the Delta.
Yeah.
One of those islands, ARCO almost drilled, but decided it was too expensive to pull a rig up on the island. This was in 1974. And so they drilled off it and missed a giant gas field. 2D seismic's been shot over it since, which I mapped in about 1992 or 3. And there's a really tremendous gas amplitude anomaly on that seismic, and the closure is bigger than the island. And I figured it was a multi-trillion cubic foot gas field. I'm just wondering why, in fact, the Bangladesh government called it the ARCO prospect. And I'm just wondering why they haven't drilled that and put it on production. At least.
I don't know. The Brits have been out there offshore. Cairn, Oxy, was out there post ARCO and made some. They had one discovery. I don't know how big it was, but Cairn and Tullow, they're still out there offshore. I don't know the size of the discoveries. I don't know where they are. They're in shallow water. I don't know where they are with respect to the island that you referred to.
Yeah, I couldn't remember which of those islands it was on that map.
Well, some of those islands you got to be a little worried about. Because the sediment load from the river system is so huge, they're not necessarily highs to structural closures. They could just be the distributary pattern that the delta is making. One of those islands, of course, back in 1970, one of the reasons that the country divided, from west to east was the poor response that the richer West Pakistan had in response to, I forgot the name of that typhoon that hit the country. It was like Badrul or something like that. But anyway, this was 1970. And, one of those islands out there was populated. Just about, 90% of the people perished. And it was a large number. I've forgotten the number, but the number of people that died in that typhoon was huge. It was in the hundreds of thousands. And so the West Pakistanis did not help the East, and this caused a huge amount of resentment. And it didn't take long for them to declare their independence. They also had a vote. The first, it was at that time, Pakistan, both parts was run by the military, and the military general promised, I forgot his name, he said, well, we're going to have elections. And from a strategic standpoint, it was a pretty dumb suggestion, because the population of East Pakistan, the Bengalis, was, 3 times what West Pakistan had. So they won. And they voted for it. Not only did they win their party, next thing they did is said, well, we want to be independent, or at least have all these, independent things, that be separated from you guys in a big way. And, the Pakistan military, which was dominated by people from the Punjab, from West Punjab, from the Pakistan port. They wouldn't have none of it, you know, and they just sent a bunch of troops there, and it started, you know, just started a rebellion. And the Pakistanis, the West Pakistanis, they were very brutal. I mean, in addition to the hurricane, that war, that insurrection, it just, which did finally end up in Bangladesh's, you know, independence. It was truly an awful couple of years for that country. I mean, I don't know what the totals were, but they must have been nearly 1 million people were lost between the hurricane and then the war. I'm getting drifting off a bit here, but any other questions? None?
Well, Tom, thank you very much. It was a very interesting presentation, and I'm happy that you introduced some geology and a nice mix of that and the little bit of the politics and the energy consumption and the potential thereof and the energy mix. That was a pretty well balanced presentation. So on behalf of the LA Basin Geological Society, I want to thank you for your willingness to participate. And I wish you the best. And let me know if you ever find anything over there or anything.
You'll hear about it.
Yeah, it'd be great.
All right, Scott. Nice talking to you. Good luck, everybody. Thanks for listening.
Hey, Scott, could I mention something briefly?
Of course.
I was asked to mention an upcoming AEG meeting. I think the Southern California chapter's chair, Matt Pendleton, was who reached out, and he wanted me to mention that Association of Environmental and Engineering Geologists, their upcoming April dinner meeting is on April 5th, a Tuesday. And I think it's up in North Hollywood. Anyway, Dean Frankuch, who's with Shannon and Wilson, is going to talk about a BNSF railway mainline dual track bridge replacement across the Mojave River. And if anyone's taken the I-15